A shark can lose a tooth in violence and not care, not because it heals better, because the replacement was already waiting. Now compare that to you. Lose one adult molar and your body does something strangely final. It bleeds, it seals, the gum closes, the bone remodels, the bite adjusts around the absence. No new molar rises from underneath. No third dentition starts. No hidden reserve tooth rotates into place. The wound heals, but the tooth is gone. That is the real mystery, not why sharks make so many teeth. Why do humans stop? The unsettling part is that the human jaw is not completely ignorant of how teeth are made. It once knew how. It did it before you were born. It did it when your baby teeth formed. It did it again when your permanent teeth formed. Even after that, fragments of the old program can remain. But in humans, that program is no longer arranged as a living replacement system. It is broken apart, muted, controlled. When pieces of it wake up in the wrong way, they do not produce a clean new tooth. They can produce cysts, tumors, or disorganized odontogenic tissue. This is not a story about sharks being better than us. It is a story about two different solutions to damage. One animal keeps replacing the blade, the other protects the bite. Somewhere between those two strategies is one of the biggest questions in regenerative dentistry. Why can a shark keep making teeth, while a human jaw learns to live with absence? To answer that, we have to start before teeth look like teeth. Before enamel, before roots, before eruption. A tooth begins as a conversation between tissues. The surface tissue folds inward. The tissue beneath answers. A signal becomes a place. A place becomes a bud. A bud becomes a shape. Eventually, that shape becomes a tooth. The structure that begins this process is called the dental lamina. It is not a tooth. It is the developmental line from which teeth are initiated. Sharks use it. Humans use it. Many jawed vertebrates use some version of this same ancient developmental logic. The signals involved are not random. WNT helps initiate tooth formation. Beta-catenin helps transmit that signal. BMP signals help shape the tissue. Sonic hedgehog helps organize growth and position. FGF signals help keep communication going between epithelium and mesenchyme. This is not one magic molecule. It is a controlled sequence. The right signal, in the right place, at the right time, held back in the surrounding tissue, so the pattern does not dissolve into chaos. A tooth is not just something that grows. It has to grow where it belongs. A molar that forms in the wrong position is not a miracle. It is a surgical problem. Tissue that keeps proliferating without structure is not regeneration. It is pathology. So the question is not simply, can cells make a tooth? The question is, can a jaw organize a tooth? That is where sharks are different. In sharks, the dental lamina does not finish its job and mostly disappear. On the tongue side of the jaw, sharks maintain a living region called the successional lamina. This is the source of replacement teeth. It stays active, it stays patterned, it stays connected to a direction of movement. New teeth begin deeper and more lingual, behind the functional row. As they develop, they move outward, they mineralize, they rotate toward the biting surface. One row is functional, behind it are future rows. Behind those are still earlier stages. The mouth is not improvising a new tooth after every injury. The replacement was already in progress. That is why a shark can lose a tooth without biologically hesitating. The system is built around loss. The shark jaw assumes teeth will fail. It expects damage. It is designed around turnover. A great white may pass through tens of thousands of teeth in a lifetime. Other sharks cycle through huge numbers depending on species, diet, tooth position, temperature, and lifespan. But those teeth are not infinite. That is the first myth to kill. Sharks do not have unlimited teeth. They have continuous replacement. Unlimited sounds like magic. Continuous means biology is doing work. The control is the point. If WNT stayed high everywhere, a shark jaw would not make a neat replacement row. It would lose pattern. If every nearby region activated at once, the result would not be an elegant set of teeth. It would be disorder. The shark's advantage is not just that it keeps the signal turned on, it keeps the signal disciplined. A bud starts. Neighboring tissue is held back. The next position waits. Then the sequence repeats. Start, confine, shape, move, start again. A shark did not solve tooth loss by making each tooth permanent. It solved tooth loss by making each tooth temporary. Human teeth are built from the opposite philosophy. Your molars are not disposable blades. They are loaded structures embedded in bone. They have roots. They have periodontal ligament. They have blood supply and nerves. They give proprioception, meaning your brain receives information from them about pressure and position. They meet opposing teeth in a precise pattern. That precision is called occlusion. If you replace teeth constantly in a mammalian jaw, you would constantly disturb the bite. A shark can afford moving cutting edges because its teeth are attached differently and serve a different mechanical role. A human molar cannot behave like that. It has to stay put. It has to meet its opposing tooth. It has to last. This is the trade. Sharks protect feeding by replacing cutting surfaces. Humans protect feeding by preserving a stable bite. But during development, humans absolutely use the dental lamina. Baby teeth form. Permanent successor teeth form. Molars form in sequence. The system is active, patterned, and productive. Then it changes. The dental lamina no longer remains as a continuous replacement source. It fragments. Cells undergo programmed cell death, called apoptosis. The once continuous developmental structure becomes scattered epithelial remnants. These are called dental lamina rests. They are not backup teeth. They are not tiny finished teeth. They are not a secret third set waiting under the gums. They are remnants of a developmental structure that no longer has its original architecture. And architecture is everything. A few pieces of a circuit are not the board. A few notes are not the score. Some molecular memory remains, but the organized line is gone. Human dental lamina rests can express markers associated with developmental and proliferative potential, including SOX2, BMI1, PCNA, and beta-catenin. That does not mean they are ready to make teeth. It means they are not biologically meaningless, and they matter for a reason that is not always comforting. When odontogenic remnants behave incorrectly, they can contribute to lesions such as odontogenic cysts and tumors, including ameloblastoma. These are not examples of successful tooth regeneration. They are warnings. They show that old developmental tissues can still have biological force, but force without structure is dangerous. This is what makes the human story more interesting than failure. The human jaw is not merely bad at regeneration. It is controlled against the wrong kind of regeneration. The break is not just a limitation. The break is part of safety. An adult jaw is not an embryo. It is already built. It has bone density. It has nerves. It has vessels. It has roots of neighboring teeth. It has a bite that has adapted over years. It has muscles loading it every day. It has bacteria, inflammation, restorations, implants, orthodontic history, periodontal status, and mechanical forces. Starting a tooth there is not the same as starting one in a developing embryo. A real tooth is not just a crown. It needs crown pattern, root formation, dentin, enamel, eruption guidance, integration with bone, periodontal attachment, blood supply, innervation, and the right angle in the bite. Otherwise, it is not useful. It is a problem. This is why regeneration is not one switch. Turning on growth is easy compared with turning on organization. The shark's secret is not just activation. It is that activation happens inside a living layout that already knows where each new tooth should go. The successional lamina is still a line. It has polarity. It has direction. It has a source side and a destination side. The new tooth is born into a system that can move it toward function. In the adult human jaw, the remnants are scattered. It repairs the wound. A clot forms. The socket changes. The bone remodels. Soft tissue closes over. The mouth adapts to the missing structure. The body chooses repair of the wound, not replacement of the organ. That choice is rational. Neighboring teeth drift slightly, and the opposing tooth erupts into the space. Clinical medical aesthetic, dark navy background with gold highlights. But it is also frustrating. From the patient's perspective, the missing tooth is the point. You experience it as chewing differently, speaking differently, smiling differently, watching neighboring teeth drift or opposing teeth erupt into space. You experience the fact that biology healed the wound, but not the tooth. That human frustration is why regeneration is compelling. It is not just science fiction, it touches a very ordinary experience. A tooth is small, but losing one changes the system. It changes force. It changes function. It changes confidence. It changes treatment planning. But biology is not sentimental. It does not care that a missing tooth is inconvenient. It cares about development, signaling, architecture, and risk. That is the tension. We want the jaw to remember, but we need it to remember safely. The shark never forgot because it never dismantled the replacement line. Humans did not erase the tooth-making language entirely, but we scattered it and restrained it. The silence is protective. The silence is also the obstacle. That is why anti-USAG1 research gets attention. USAG1 is connected to developmental pathways involved in tooth formation. Blocking it may release a break in selected contexts, especially congenital tooth agenesis, where people are born missing certain teeth. But this is not routine dentistry. It is not a consumer tooth regrowth product. It is not proof that any adult can grow a perfect third set on command. The important idea is more specific. If a developmental break exists, and if researchers can release it in a controlled patient, at a controlled site, during a controlled window, tooth formation may be more accessible than it once seemed. But the word controlled is doing most of the work. Signal without structure is risk. Growth without pattern is risk. Potential without restraint is risk. The future of tooth regeneration will be measured by whether we can make cells active. It will be measured by whether we can make them behave. Where does a new tooth begin? What keeps the next tooth from beginning too soon? How does the signal stay local? How is shape determined? How does the tissue know when to stop? How does the tooth erupt without damaging neighboring structures? How does it become part of a bite instead of a mass? Can we borrow the logic of replacement without losing the architecture of a mammalian bite? Can we release a developmental break without removing the guardrails? Can we build a tooth without building a tumor? That is the boundary where the science becomes serious. The answer will not be a viral headline. It will not be a pill that casually gives everyone a third dentition. It will probably be slow, selective, carefully monitored, limited to specific indications before it expands. And if it works, it may look less like magic and more like guided development. The more you look at the shark and the human jaw side by side, the less it looks like one animal won and one animal lost. It looks like evolution made two different bets. The shark bet on replacement, the mammal bet on precision. The shark kept teeth moving because its life made broken teeth inevitable. The mammal stabilized teeth because its chewing system demanded exact contact. A shark can lose the blade because another blade is already being made. A human loses the molar and the body protects the remaining structure. One strategy accepts constant turnover, the other accepts finality. And somewhere inside that finality are fragments of an older possibility. If dentistry ever learns to speak that developmental language safely, the goal will not be a mouthful of endless teeth. The goal will be quieter and harder, one tooth, in the right place, at the right time, with the right shape, integrated into the bite, and stopped before biology crosses into disease. That would be the actual miracle, not unlimited teeth, controlled teeth. Because a shark's mouth is not impressive because it is chaotic. It is impressive because it renews without losing order. And the human mouth is not limited because it is primitive. It is limited because it chose a different kind of order. The shark kept the replacement line. Humans kept the precision bite. Now, regenerative dentistry is asking whether those two worlds can ever meet. Not as fantasy, not as hype, but as a controlled return to a program the human jaw once knew. Evolution did not erase the tooth-making story. It edited the ending. Next episode, elephants and manatees solve the tooth problem in a completely different way. Real biology, real mechanisms. Join us for episode 1, Continuous Teeth, Human Breaks, and the Future of Regeneration. I'm your host, and this is the Shark Tooth Factory.